Alright, so my name is Siti Khadijah. Okay, so as a matter of formality, you can just call me Dr. Siti. Okay, alright. So please make sure that you are in a right class, discrete structure. Okay, code CSC3003 is semua first year kan? Yes. Alright, and then the synopsis for this course is we are going to cover mostly on mathematics lah. Alright, and then inshallah we will see on the applications of those mathematics applications in computer science. Alright. Gife, can you hear me? Gife? Alright, and Dr. Aziah is the penyelaras, okay, for this course, and then the credit for this course is 3 plus 0. We are not going to have a lab, okay, just a theory, and then no prerequisite, and then what else? So this is the CO, the course learning outcome. So basically, right. So basically, based on the learning outcome, we will assess you. We are going to assess you based on this learning outcome. Okay. So first, you must be able to describe the discrete mathematical concept related to computer science. So basically, we are going to assess you in test 1, some part of assignment, and also final exam. Jangan serius sangat lah. Tegar sangat. This is your first class for today? Yes. Wow. Jangan stress sangat. Nanti you all stress, saya pun stress juga. Okay? So and then the second one, we are going to assess you in terms of numerical skill. NS is numerical skill. So at the end of this course or at the end of this each module ke topics ke, you must be able to analyze problem to suggest solution in the form of modeling calculation. Okay, so we will introduce to you some theory, and then we are going to give you some problems, and then based on your knowledge from the theory, you must be able to solve the problem lah. Okay, alright. And then the last one is you must be able to solve problems related to computer science using discrete mathematical methods. So this one, if you notice, the code here is LL, long learning. So basically, the questions that comes from this particular part maybe not really direct lah. So we are going to use a bigger problem. Okay, and then by using your Google searching skills, okay, so you need to solve that. Clear? Okay, alright, good. And then all these things I don't think you need to know that. Alright, so this is the SLT, student learning time, that we decide for you. Alright, so if you notice here, for the bab 1 or topic 1, okay, so it will relate to CO1. If you remember our CO1 just now, C4 and cognitive describe. So chapter 1 and the bab 1 or chapter 1 and chapter 2, it will reflect the CO1. Okay, so the guided learning 6. So this one is for week 1 and week 2. So it's about because 1 week you have 3 hours for this kind. So 6 hours meaning 3 lah, this week and next week, right? And then this is for the e-learning for your self learning. Same goes to this one, right? SLT. This one, do you want to have this Oh, nak. Okay, so I will share this one lah for you nanti later. Alright? You dah boleh access Putra Blast? Dah boleh dah? Okay. So I will upload because they said that Putra students still cannot access, so that's why I'm not uploading anything inside the Putra Blast yet. Alright? So I will upload this in Putra Blast. Okay, this is important for you. Okay? So this is the percentage division. Okay, so test 1, we are going to have 2 tests. Test 1, it will cover 15%. Test 1 will happen maybe week 4, 5, 6 in that duration. Test 2 after week 8. Normally we will do that in week 9 or 10. Right, and then it will cover as well 50%. And then assignments 10%. And then you are going to have project 20%. Project you will need to solve it in group. Okay? Clear? Alright. And then final assessment, final exam lah, macam biasa, it will cover 40%. Okay, so you can start to aim lah nak score dekat mana and right? Any question? Yes? No? Excited nak belajar. Okay. So this is the references. So I will share to you. I will attach the textbook. Kalau boleh attach, because the textbook is quite big, and I'm afraid Putra Blast cannot capture dia punya storage tu. I will try. Okay, for the textbook, because usually for my class, for the quizzes, I will look into your test 1. If let's say all of you can score for 15%, ataupun maybe 13%, so I will not give you quizzes. But if there are some of you, maybe you still are in adapting process, so you cannot really grasp whatever you learn during the class, so I will provide you with quizzes so that it can help every one of you. Okay, so orang dapat makan rendah pun saya dapat quiz. Okay ke macam tu? Okay, alright. So tu je lah kot. By the way, siapa ni? Liu, any question from you?
Yes, teacher. No.
No. Everything okay for you?
Yes.
Yes. Alright, good. Okay. Alright. Alright. So, okay. Alright. Before we start, can we know each other first? Right. Nak start daripada sana ke siapa nak buat dia kerja? Oh, lelaki 5 orang je. Sebab my previous batch, your senior setahun lebih, ramai lelaki. Tiba-tiba tahun ni batch kan macam sikit. Yang lain pergi mana? Pergi Dr. Bank kan? Betul memang tak ramai. Oh, good. Okay. So, introduce yourself. Siapa nak volunteer? Your name, and then your name, nama glamour, your glamorous name, apa lagi? Where are you from? Age. Boleh kot. Lagi? Tahun bila? Saya nak tahu lagi kita berapa lama kan? Okay, Zama nak start. Cepat. Hari ni kita relax je. Tak apa ke? Okay, kita santai. First day kan? Okay, siapa nak volunteer? Okay lah, lelaki dulu lah. Gentleman. Diri tak kisah sekali.
Okay. Saya Muhammad Zarif Iskandar. My name is Muhammad Zarif Iskandar. They call me Zarif or Zarif. I'm from Kedah. Sumatera.
Umur?
19.
Apa? 19 plus. Saya tengah sekolah ni besar semua. Zarif, saya walaupun saya tanya nama, tapi dia kedua saya akan lupa juga tau. Tapi nama muka je kenal, tapi saya lebih confuse awak dengan sini awak atau apa. Zarif, saya cuba ingat.
Hello everyone, my name is Nur Fahmi Putra. You all can call me Mi, and for Chinese student, you all can call me Xiaomi. And
Mix ke?
no, I have a lot of friends Chinese.
Oh,
Chinese.
okay.
And I am from Perlis. My age is 20.
Apa ni?
20. Dash 02.
I'm from Ipoh, Perak. I'm also 20 years old. So also 02.
Siapa nama tadi?
Manteng.
Manting.
Just call me Manteng.
Manting. Zarif. Tadi apa? Zarif. Manting. Terusnya?
Hello guys, my name is Nikma Alia binti Mak Sofi. This is my voice if you wonder, deep voice. So I'm 22, probably older than most of you. I actually from Polytechnic.
Okay.
So can call me Nick. So that's all. I'm from Kelantan.
Kelantan. Okay. So I should call you apa tadi?
Nick.
Nick.
Yeah.
Nick, Manting, Fahmi, Zarif. Saya belakang lupa dah. Tergabur dah. Next.
Hello, my name is Siti Nadira Farzana. You can call me Nat. I'm 19 years old. I'm from Kedah. I'm batch 03.
When you say batch 03 tu maksudnya apa
2000.
Oh, lahir. Nampak ya. Dia macam you all juga kan, lama cuti kan, masuk universiti macam slow sikit. Sama lah kita. Okay, alright, batch 03.
Hello everyone, my name is Sophia binti Muhammad Sri. You can call me Sophia. I'm from Seremban Negeri Sembilan. I'm 19, batch 03.
Next.
Hi everyone, my name is Nur Syahida Syahira. You can call me Syahida or Syida. I am from Gombak, Selangor, and I am 20 years old, batch 02.
Hi, my name is Karina. I'm from Gombak, Selangor, and I'm 21 years old.
Kawan ke? Sebelah ni? Sama sekolah? Oh tak.
I'm actually a transfer student. Previously, I was in Faculty of Engineering.
Oh, okay.
From University student in University.
Macho lah you. Wow, terus kenapa?
Share sikit lah.
Okay, tak apa.
Okay, my name is Vishwa. I'm from Selangor. My age is 19 and I studied at College Matriculasi Selangor. That's all.
Nak PA saya
Hah?
Vishwa. Anak PA saya ke? PA awak?
Sama.
PA awak dekat? Okay.
Thank you.
Hai Vishwa. Okay.
Assalamualaikum and hi everyone. My name is Mirza Adham. You can call me Mirza or Michan. I'm from Bami, Selangor.
Oh, bagus.
I'm from Bami, Selangor and I am 19 years old.
Bagi kat mana?
Bandar Seri Putra.
Oh, BSc.
Hi guys, my name Haras Irfan. You guys can call me Haras or Choi.
Oh, okay. Joy. Tadi sebelah tadi apa tadi? Mirza.
Mirza.
Panggil apa tadi? Micha. Micai. Yang ini Choi.
Ah,
Choi. Micai, Choi.
I'm from Maha. I'm 20 years old.
Okay.
Hi, my name is Lizan Adam
siapa dengan ni?
Saya Kelantan.
Oh, saya Kelantan. Okay, nampak tak? Dia dah mula kan, dah mula confused. Okay, next.
Hi, my name is Adisa from Kelantan. You can call me Adisa and I'm 19 years old. Before this, I studied in Melaka in College Matriculasi.
Okay. Buka sikit mas tadi. Sorry saya minta.
Assalamualaikum. Hi, my name is Nurabeta Zen. You can call me Amy. I am from Kedah, but now I live in Kedah. I am 19 years old, which was
AB ke Amy? AB.
Assalamualaikum. Hi guys. My name is Nur Jannah. You can call me Jannah or Jan. I am 19 years old and I live in Ramat Selangor. I used to study in College Matriculasi Selangor.
Assalamualaikum and hi. My name is Aini Hanani binti Nursyahman. You like call me Aini. I'm from Kelantan. I'm 19 years old. Batch 02.
Okay. Amy, AB.
Hi, my name is Naja Biasan. You can call me Naja or Rija. My age is 21. I'm taking diploma before at UiTM Jasin.
Oh, Melaka ke?
Yes, kat dalam Melaka.
Rio. Oh.
Batch 01.
Hi, Assalamualaikum. My name is Nur Alia binti Kamari. You guys can call me Alia or Alia. And I am from Selangor, living Puchong. I am batch 01. Previously, I studied diploma UiTM Arab.
Diploma Arab ambil apa?
Diploma Science Computer.
Assalamualaikum and hello everyone. I am Nur Fazli Fakrana. You can call me Fazli or Faz. I live in Kemaman, Terengganu. Previously I study at College Matriculasi Perlis and I am 19 years old, batch 03.
Okay. Saya cuba dah ingat dia. Okay, Liu. Hi, Liu. Do you mind to introduce yourself to our friends here? Liu and Zhang Yifei.
Yes.
Yes, maybe you can switch on your camera for a while. So that your friends can, I'm not sure whether you can see. Oh, gitu kan, kamera kita besar sangat. Okay, say hi everyone.
Hi.
Okay, alright. Okay, Leo, come introduce yourself.
Okay. Hi everyone. I come from China. My Chinese name is Liu Xurui. My English name is Cassie. You can call me Cassie in the daily life. Nice to meet you too. Nice to meet you all. Thank you.
Okay, hi. Say hi again. Okay, alright. Okay, Liu. Okay, Zhang Yifei. I think Yifei's connection is not so good, maybe because he or she keeps on in and out. So it's fine. When he or she comes back, then we will call him or her to introduce herself. Alright. Okay, so you say sorry, Masya Allah. Saya tak ada nak tirikan orang tau. Sorry, tak perasan. Okay. Okay. Next. Okay, thank you everyone. So I can notice that maybe most of you are from north part of Malaysia, kan? Okay. Johor tak? Johor tadi tak ada. Tak ada orang Johor batch kali ni. Okay, saya Siti Khadijah. I'm Siti Khadijah. I'm from Batu Pahat, Johor. Saya orang Johor gitu. Apa lagi? Umur rahsia. Secret, rahsia sikit. You boleh adjust lah kalau you all lahir 2003. That time 2003. SPM saya rasa masa tu. Kira lah sendiri masa tu. Okay? Kira lah sendiri kita nak sebut. Okay. So, for today, kita terus start our first chapter. So, I am so sorry because I haven't upload the notes. Ke you guys dah dapat from your seniors? Not yet. Dah jumpa seniors ke? Senior, dah jumpa dah? Okay. Dah minta nota dengan dia? Belum. Cuba minta nota dengan sini. Okay. So, tak apa. Nota nanti saya akan upload. So, So, kita start je lah. For the first chapter. InsyaAllah, we will cover on fundamental of logic. Windows. This one. Okay. Kalau saya jadikan dia macam ini, apakah yang akan berlaku? I forgot to ask. Is this course is your first choice? I mean this program. How many of you actually are not planning or dreaming to be in this course? Ada ke? It's fine lah. Saya tak penalize ni. Tanya je. Oh tak pernah minta. Yang tak minta. Yang tak minta. Yang tak pernah terfikir, termimpi. Bercita-cita untuk masuk ada. Boleh je. Okey je. Berapa saya nak tahu? Jangan tak pakai. So, when first time got the offer, it says that Bachelor of Computer Science in the bracket multimedia computing. So, what actually comes into your mind? Multimedia, arts multimedia lah. Grafik tu yang Photoshop ni lah. Video editing semua lah. Yang melakukan okay. So, when you decide to just bilang go and register. On last Friday, KJ, Dr. Masuna ada brief sikit kan about the course. So, ada tak macam you have now a different perspective. Okay. So, a different perspective tu apa yang kita fikirkan? lupa tu rasa macam habiskan lepas tu nak lapar. Ada ya? Okey je, saya okey je. Okey je. Okey nak lapar. Saya cuma nak tahu je, it's fine because when cerita sembilan, masa saya pergi pun saya pun dapat course dialog. Okay, tak pernah terfikir pun nak ambil course tu, kita dapat kita nak course so itu je tak nak tahu, but it's fine, it's okay. Okay, it's fine, cuma saya nak tahu tu je. Alright, so for today's lecture, we are going to cover on fundamental of logic. Alright, so in this course, in this chapter, it's quite simple actually. Alright, so because I believe that you familiar with this notation. Yang ini mungkin tak, tapi at least these two symbols. Familiar tak? Tak pernah. Tak pernah. Yang ini they describe and this one describe all. Saya lupa nak saya terlupa lah. Patut saya kena cakap sekejap Cassie, you can click on the gem file on the chat box. This is where I will do the explanation. Alright. Okay, so I hope that you are familiar with these two, at least lah, with these two symbols. Okay, so basically in this chapter, in this topic, alright, in this topic, you will identify what is the proposition. Okay, what is the proposition, how to create a proposition, and how from a proposition you can translate it into some mathematical model, and then from that mathematical model you will use that for the programming. Alright, everyone you have an experience doing a programming, right? Ada tak? Tak ada. Is that experience? How many of you have experience on doing a coding? Tak pernah langsung belajar Okay, tak apa. Nanti saya akan belajar lah. Okay, cumanya nanti you akan tengok lah how from the proposition itself you can translate into a symbols, and then from that symbols you will translate into coding. Alright? Okay, so but first thing, okay, so this is the LO for this course, for this chapter. So you must be able to understand the rules of logic and know how to construct correct mathematical arguments, distinguish between valid and invalid mathematical argument, solve related problems of logic, and then discuss the applications of logic to computer science. Remember, when we talk about computer science, it's about logic. Okay, logic and syntax. These two things lah, it must come together. Even if you have the logic, but you do not know the syntax, you still will not be able to solve the problem. Boleh? Alright? Okay. So this is the outline. Propositional logic, the language, the application, logical equivalence, and then we will look into the predicate logic, the language of quantifiers, logical equivalence, and rules of inference. Okay? Alright. So this is the general application of discrete mathematics. So basically this is just general lah of this course. Alright? So So by using a discrete knowledge, you will be able to calculate possible ways to choose a valid password on a computer system or security. Okay. Alright. So basically, I can say that the first thing it relates to statistics. Okay, statistics. And then second, you may be able to identify spam email messages. So basically, if you notice in Gmail, they have one part spam. So how they identify that? They are basically using this knowledge, the discrete knowledge. How to they have their own algorithms lah. But then the algorithms, the knowledge comes from discrete knowledge. Alright? You may be able to encrypt messages so that no unintended recipient can read it. Same. And many more. Lah, a lot nanti. Kita tengok. Okay? We will go through. Alright. Propositions. So, proposition is a declarative sentence that is either true or false. Alright? So, this is the example. Let's say we look the first name. Her name is gorgeous. So, this is a statement. Okay, and this statement, it has what we call as truth value. Okay, so when I said truth value, her name can be gorgeous, and at the same time, her name may be not gorgeous. Okay, right. If you compare this statement with this one, hey you. Do you think this one is a statement? Okay. What about the above it? Do you like to have a dinner with me? Okay. What about this one? Alright, good. Nampak pula yang bawah ni. What about the last one? What about the last one? Okay. This one, it can be a proposition if we know the value of D. Okay, but if let's say you do not know the value of D, then this one eventually will not be a statement or proposition. Clear so far? Okay, so this one obviously a statement, okay, or a proposition. Remember, proposition is a statement that has truth value. True or false ni, we call it as truth value. Right? Okay. Any question? Okay ke? Clear so far? Boleh Okay.
Yes.
Okay. How to construct the proposition? So we have a proposition, and that proposition we can present it in. We can present the proposition by using propositional variables. Okay, for those who have an experience doing a programming, if you notice, usually, bila you nak start, when you start to do a programming, you need to, you need to declare a variable. Remember? So let's say the problem is to solve A plus B equal to C. Let's say this is the given problem. So I want you to code this thing. So the first thing that you need to do is you need to declare. First, you need to declare the type of A, B, C. Okay, let's say we say that A, B, C is an integer. So we will use int. Int is integer. A, B, C. This is the declaration lah first. Then the next step that you will do is you will insert a value, right, to this variable. So now we are actually start to construct the proposition. Okay, let's say the A is equal to 3. B is equivalent to 2. and C is equivalent to A plus B. Okay, see, this is the simple example. Okay, I can give to you right now. Clear so far? Alright, good. Okay. So we are actually giving the variables to this statement. For instance, like this one, the statement is her name is Mei Ling, and we assign P variables to this statement. Alright? And then this next statement, the size of his food is 12, and we assign the Q to this statement. The truth value of a proposition is true, and we will denote it with capital D if it is a true proposition. And if this statement is false, we will denote it with capital F. We denote it with capital F. Right, clear? Okay. So if let's say in this case, her name is Mei Ling. So the truth value for this statement is true, then we will letak capital T kat situ. There. And if let's say the size of his food is 12, but in reality the size of his food may be 15. So you can put a bracket here and then put capital F. Okay? Clear? Boleh? Alright. Ngantuk tak? Sikit. Baru start, baru 6 slide kot. Sikit lagi. Okay. Alright. Okay. We move into propositional logic. So propositional logic or propositional calculus is a propositional that deals with logic. Remember the sign that I mentioned just now. This one. So by having these two signs here, if let's say you have two proposition, two statement, so you can combine these two statement by using these two symbols. Okay. Actually we have more lah, but in this example I just mentioned two. If let's say my name is Siti and I live in Bangi. So what is my first statement? Okay, the second statement? So do you notice the word in between? And, right? So by combining these two, actually we are actually creating the compound proposition. We combine these two. Okay, to combine the two, we call it as compound proposition. Okay, so we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We have 5 logical connective, okay, that we can use to form the compound proposition I mentioned just now. First, negation with these symbols. Alright. The negation is these symbols. And then this one, we call it as conjunction. Okay? And then the second one here, this one, is disjunction. And then we have the arrow. Okay, we have the arrow. Arrow is for implication. And then we have 2 arrow here, macam gini. Maaf lah ya. Gini, we call it as biconditional. Right? Okay. Okay. So now we look into the first logical connective for the negation. Okay. The negation, kalau if you notice the word itself pun, is actually near to negative. Negation, negative. Right? So that's why if you have the proposition that comes with this connective, it means not for the case of that variable. Let's say I say my name. Okay, sini Let's see. Silah. My name is Opa. Alright. And then I add negation symbol. Ni. Okay. So now this statement will become what? Clever. So now this one is my is not right? So you can see the relation, right? When you have this connective in front of your statement there. Clear so far? Alright. So we have what we call as a truth table. Alright. So for this one, if let's say your statement is true, alright. Okay. So when you have this negation here, it will give a false statement. And then if let's say the P, the truth value for the statement P is false, then the truth value for the negation P will become true. Jadi lawan. Right? Okay. So example here, if P denotes the earth is round, and then for the negation P, it denotes that it is not the case that the earth is round, or simply the earth is not round. Senang ni lah. Okay? The first one ni easier sikit. So now we move into the conjunction. Okay, kita lihat kejap lah. Boleh? So siapa yang nak pergi toilet, boleh pergi toilet, nak minum air. Nah, ni boleh, okay? Kita lihat 5 minit. Alright? While waiting for that, if you have any question nak tanya, boleh je.
Kira yang Y D plus 2 equals 75 tu bukan proposition.
Macam mana?
D plus 2 equals 75 tu bukan proposition lah.
Itulah, dia bukan kalau kita tak tahu value D tu apa. Kalau in the for instance dia just macam gini je kan, D plus 2 equal to 25. Then ini bukanlah. Tapi let's say ada satu lagi, D plus 2 equal to 25, comma D equal to 17. So kalau in that example, yang itu dia adalah proposition sebab kita tahu value D. Itu yang saya kata untuk kes yang ini dia boleh jadi dua. Satu, kalau dia just macam gini je, dia bukan proposition sebab kita tak tahu pun value D. Tapi in keadaan ataupun condition, let's say dia buat cerita adalah D plus 2 equal to 25, comma D equal to 17. Itu adalah proposition. Cumanya proposition dia tu ada false truth value Sebab kalau D17, 17 tambah 2 kan 19. Macam mana dia kata D17 tambah 2, 25? Gitu.
Tapi saya confused because D tu literally dia dah give it the value sebab if kita pindah 2 kat sini, kita dah dapat value D.
Awak fikir logik macam gitu. Itu dia macam mana? Itu yang saya kata dia ikut statement tu. Dia bukan ikut operation. Statement by itself. Apa yang diberikan kepada awak. Macam gitu. Boleh? Sebab yang ni kita cuma nak bagi tahu adakah itu statement ataupun bukan statement. Itu je. Dia bukan operation. Boleh? Okey, sambung So, okay. Alright, so now we move to next connective, which is the conjunction. And the conjunction P and Q of propositions P and Q is denoted by these symbols. So remember, for the connective, the purpose of us having the connective is to combine two or more statements together. Gitu. Right. So for this one, itulah for the conjunction, the symbol is this one. So the conjunction could also be written as P by Q. Right. So if example here, if the proposition is she is cute but talkative, so we can rephrase the statement into she is cute and talkative. Gitu. Alright. Okay. So the truth table for the conjunction is as this. So if let's say your first statement or the P statement has true truth value and the Q statement, Q or Q proposition has true value, the truth value for the Q is true, then the conjunction of P and Q is true. Alright? So for the rest, if let's say the P is true, the Q is false, then the conjunction is false. And then for the, if the P is false, Q true, same, it will give false. If P false, Q false, then the conjunction is false. So we can do a conclusion here. For the conjunction statement to be true, both statements must be true. Okay, the rest it will give you false. Okay, remember for the and or for the conjunction it must be together. Kalau kita belajar dulu sekolah kan. Okay, boleh. Right, okay. So for the disjunction, so the disjunction it denote or it present by these symbols here. Okay, for the disjunction. So the truth table for the disjunction is as this. Okay, so the conclusion that we can make for the disjunction, if let's say the P and the Q false, then the disjunction will become false. The rest will give you true. Gitu. Clear? Okay, yeah. So the example here, if let's say the P denote as I am at home and Q denote as it is raining, then if we do the disjunction, it will be I am at home or it is raining. Right? Okay. So for the connective or, for the or, we have inclusive or and exclusive or. Alright? So for the inclusive or, okay, we can say that if one or both of Q, P and Q, it must be true, then the inclusive or is the conjunctive. So if you see the example here, the statement here, students who have taken CS202 or Math 120 may take this class. So we assume that the students they might have take 202 only. It may have take 120 only, or they have take both. Okay, so that's why we call this as inclusive. Semua tu terlibat, all included in that package. If you compare this example with this one, the exclusive or, for the statement soup or salad comes with this entry. So from this statement here, automatically we can see that this entry will come only with soup or salad. Only one will come together. Will come for the entry. Nampak tak dia punya difference tu? So for the second case, we call it as exclusive or, because you have to choose only one. Clear? Ada yang tak clear Kalau tak clear you okey je angkat je tangan. Memang tugas saya dibayar gaji untuk memahamkan awak belajar. So jangan takut-takut. Okey Liu? Oh Liu.
Yes, teacher.
Okay. You clear for this one? The inclusive or and exclusive or?
Oh, inclusive for.
Do you have any question for this part? For the inclusive and exclusive or?
No.
No. Okay Clear Clear. Alright. Okay. So this is the truth table for the exclusive or. Okay. So this is basically for your general knowledge only lah. Okay. So but it's good if you can take into account for this one. Okay. Okay. So now we move into the next connective, which we call it as implication. Remember implication, the symbols for the implication is as this one. Arrow. The arrow. Alright, the arrow. Okay. If P and Q are propositions, then P arrow Q is a condition statement or implication which is read as if P then Q, and it has this truth value. Right? So if let's say the P true, the Q true, then the implication will be true. If the P true, the Q false, the implication will be false. If the P is false, the Q true, the implication will be true. If the P false, Q false, the implication will be true. For this case, the if P then Q, the P we call it as premises. Salah. Sini. Macam ni kan? If P dan Q, the P we call it as premise, and the Q is consequence or conclusion. Alright? So and if you notice for the truth table here, alright, we can say that for the first three kan, kalau you notice, this implication, it looks like it follows the conclusion, except for the last one here. The last one, if the P is false, the Q false, then the truth value will be true. So this one je lah yang lain sikit. Okay, the bottom three ni, it looks like it follows the conclusion. Easy for you to remember for that. Boleh ke? Okay ke? Kenapa awak terbenung? Risau kita. Alright. There is an example here. If P denotes as I am at home, Q it is raining, then the implication of PQ denotes if I am at home, then it is raining. Okay? This for the understanding for the implication. If in P then Q, or the implication of P and Q, there does not need to be any connection between the antecedent or the consequent. Okay, there might be a case where you can see the P and the Q, there is no connection at all. For instance, if I'm at home, then she is wearing a red kebaya. Dia tak nampak, dia tak ada connection. So it is not necessarily for the implication to have connection. Gitu. Right. So the meaning of PQ depends only on the truth values of P and Q. Right? The meaning of the truth table just now. This one. The truth value ni, it does not need for the P and Q to be connection. Right? Okay. This like in ordinary English language. Gitu. Alright. So for instance here, if the moon is made of green cheese, then I have more money than Bill Gates. Jauh nak dua ni kan? Tak ada. If the moon is made of green cheese, then I'm on Harvard. So if 1 plus 1 to 3, then your grandma always contribute lagi lah. See? So dia tak ada kaitan langsung lah. So that's why we are not use the truth table ni dalam English communication yang biasa. Okay, dalam mana-mana bahasa. Okay, clear? Boleh? Alright. Okay, so this is other ways of writing the P arrow Q. Okay, this is it gives the same meaning as P arrow Q. Gitu. Okay, so mungkin in your test ke, in your final ke, maybe your quiz ke, maybe I will use these terms lah. So if P dan Q tu dia macam senang kan nak ingat kan. Tricky lah sikit kan. Gitu. Alright. Okay. So a useful way to understand the truth value of a condition statement is to think of an obligation or a contract. If I am elected, then I will lower taxes. Biasa dengar kan? In next few months, you will hear something like this too, right? So if you get 100% on the final, then you will get an A. Okay, so for the first statement here, if let's say the politician is elected and they do not lower the taxes, then the voters can say he or she has broken the campaign pledge. Gitulah. So this is another also way lah of us to use the implication. Boleh? Clear? Alright. Okay, so this is the another, we can say, compound proposition, but this one we are actually doing some operation into this implication. Right? So we have converse, we have contrapositive, and we have inverse. The original is this one, but when we say the converse of this, it will give us this one. Okay? And then the contrapositive, this one, like this. The inverse is this one. Alright? So how are we going to say this is the converse ke, this is the contrapositive ke, this is the inverse ke? We can use truth table. We use the truth table, then we compare the truth value. Boleh tak? Okay, alright. So this is the example here. Find the converse, the inverse, and the contrapositive of this statement. The home team wins whenever it is raining. Alright. Ni bukan ada soal ya. Ni adalah satu kesilapan. Mari kita delete. Okay. Okay. So whenever Q. So this will be our Q, right? This will present our Q statement. Q, and this will present our P. So how I know this? Because I have this keyword here. Whenever. If you compare back to this one, you can see this one. Q, never P. So you must tengoklah, you must look at the keyword there. Alright? So that's why from here I can say that Q whenever P. Okay, so this is our Q, this is our P. Alright? So we can say that this is our, this statement is P, Q. So and then from here you can kenapa lain lain pula jawapan dia lah. Nanti saya betulkan balik jawapan dia yang ini. Tapi you can try and then we can discuss this one. So I will check that. Alright? Okay. So far okay tak? Ni je saya bagi tahu jawapan. Itu saya letak jawapan yang betul. Alright? And this one. Oh, sebenarnya kat sini. Alright. So alright. So okay, the answer is here actually. The answer is here. Tapi you can try je sekarang. Kalau you nak try sekarang ke? Sekarang berapa dah? Cuba 23. Tak apalah, saya skip dulu. Yeah? Right. So we move into the biconditional. Right? So for the biconditional, it has this symbol. This one. 2 arrows. Both right and left. Alright? So for the biconditional, if P and Q are proposition, then we can form the biconditional proposition P, Q as P if and only if Q. Okay? Okay. So if and only P if and only if Q is true when if P then Q and if Q then P are true, and false if otherwise. Gitu. So when you read this statement, can you imagine the truth table? The truth table will have, saya rasa dia kan jadi macam gini. Dia akan jadi mungkin P, Q, this one, ni true. Contoh if this is true, then this one will true, this one also true, then ini pun akan true. Okay, let's say kalau this one is false, this is true, apa akan jadi kat sini? Ini akan jadi true, ini akan jadi false, ini akan jadi false. Notice tak? Do you notice why here is false? Because of this statement. P if and only if Q is true when if P then Q and Q if Q and P are true. This one true, this one true, then only if and only if P Q true. This one, kalau you notice, if P then Q true, but then if Q then P false. That's why here, false. So for this one, for the biconditional to be true, these two must be true. Boleh? Nampak? Dia punya ayat tu. Mantul Betul-betul sikit lagi. Okay. Alright. Inilah contoh dia. Okay, if you notice here, kan? If P dan Q true, if Q dan P true. Dan ini pun sama juga. This one, if this one true, then this true. But for these two, it false because there is a false here and false here. Boleh? Clear? Okay, alright. Move Okay, so this is an example of truth table. So if let's say I'm giving you this statement, something like this lah. Okay, so now I ask you, I want to know the truth table of this whole statement. So how are you going to do? You kena list down kan lah. So that is the formula to know how many rows. Here. The formula to know how many rows, the formula is 2 to the power of n, where n is the number of variables. Clear? Boleh? So it's a 2 to the power of n. If you notice, from negation until biconditional. Negation, we only have the example for the truth table. Just now, we only have one variable. Rasa tak? And the truth table, one variable. And the truth table, we have dua sahaja. Kalau perasan tadi. P, negation P, if this true, this false. If this false, this true. So we have one variable. So by using this formula, 2 to the power of n, where n is a number of variables, we get 2 to the power of 1, 2 rows. Okay, so this for the negation. For the conjunction just now, I give you an example. We have two variables, right? And P and Q. Good? Okay, so by using this equation again, so we plug in the 2 to the power of n. For the conditional case, the n is 2, so 2 to the power of 2, we have 4. So we got 4 rows. So if we look back into the slide, for the conjunction, kan? There are 4 rows here. So you can use that formula to know how many rows. So back to our example just now. This one. How many variables we have here? P, kan? So we have P. Maaf ya, my handwriting memang ni lah macam you nampak. P, Q, R, right? So by using this formula, we have 2 to the power of 3 equivalent to 8 rows. So if you check these rows, we have 8 rows. 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 possibilities. Right? Okay. So we have P, we have Q. So the first statement, the first compound is P, disjunction Q. Alright? So if you see here for the first row here, P or Q, true or true, give true. Alright. So for the R, we have a next column for the R. So we have the R as true here, and the negation of true for the R is false. So now we have if true for the junction here, true false, it will false. Clear tak itu? Any question? No. Okay. So susunan dia for the arrangement for this one, it's up to you. It is not necessarily for you to follow this. As long as you can provide the P, the Q, the R, the truth value, and how you come out with the truth value here, only that. And then please make sure that you have the correct rows and the correct combinations of the P, Q, and the R. Okay, so the last column here, I will check whether it's true or not. Boleh? Clear? Alright, good. Okay, so now we are moving to equivalent proposition. Two propositions are are equivalent if they always have the same truth value. Alright, so let's say here we have the implication, the if P then Q and the contrapositive. When you see this soalan kan, this question like this, show using a truth table that if P then Q is equivalent to the contrapositive here. So based on this question, these two statements, these two compound, it must be equivalent. It's just they ask you to show. Okay, so if let's say bila you buat tu, suddenly you tak dapat equivalent, then you kena make sure the equivalent. Okay, macam cakap tu. Okay, so if you look to here, so this is the statement, kan? If P then Q, and then the contrapositive value. So the equivalent, when we say that these two compound is equivalent, you can see that the truth value for both same. So whenever you get this question, if let's say this one true, this one false, so it is you just must to make sure that you get true. Kalau tiba-tiba terdapat true false kat sini, something is not right in here. Check back. Okay, so jangan careless lah yang ni. Ramai student dia careless ni. Bila kita kata show, when we say show, meaning that this, it must have this. Gitu. Boleh? Okay? Alright. So whenever you get the true value like this, then it shows that this true compound is equivalent. That's the word for the equivalent. Alright? So this is another way, another question. By using a truth table, show using truth table that neither the converse nor inverse of an implication are not equivalent to the implication. So, okay, so this is the implication, alright, and this is the converse, and this is the inverse. So if you see here, this is our original kan. So the truth value for the P and Q, this one is true, okay, fine. But then for the second and third row, it doesn't match. Kalau you compare, yang if P dan Q dengan yang converse ni, dia tak match. Yang ni pun dia tak match, yang ni pun, dan third row pun dia tak match. So kalau macam ni memang dia tak lah. Sebab dia kena semua sekali kena keempat-empat row ni kena equivalent. Boleh? Clear yang itu? Boleh? Okay, precedence of logical operators. So I think this one pun maybe you familiar, maybe you are not familiar with the logical operators, but then the precedence, kan, mathematical operations, semua kan, mana nak buat dulu semua. So if let's say you found like this one in any question, then you must know which one must be solved first. Gitu. So for this one, if let's say you are giving this, so this is equivalent to P O Q, kan, P O Q tak, you kena solvekan dulu. Okay, and then this one is nombor 1, and then this one is nombor 3, and then you baru solvekan the implication nombor 4. Okay tak yang ni? So kalau you dapat yang ni dulu, you selesaikan ini dulu, dapatkan ini, value ni dalam truth table, and then next you solvekan yang ini, dan yang last baru you solvekan ini. So for this one, let's say we have P, okay. So this one nombor 1, and then ini nombor 2, and ini operation nombor Alright. Any question for this one? Clear? Okay, good. Okay, yang ini system spec. Oh, okay. So this one. So from slide 25 until 33, it's an application of the logic. This one. So the application of propositional logic translate English to propositional logic, system spec, Boolean searching, and logic circuit. Alright. So logic has many important applications in computer science and numerous other disciplines. For example, it is used in the spec of software and hardware. Rule of logic can be used to design computer circuit, to construct computer program, to verify the correctness of program, and to group expert system. Logic also can be used to analyze and solve many familiar puzzles. So, translating English sentence. English and other human language is often ambiguous. Steps to convert an English sentence into a propositional logic. First, you identify the atomic proposition and represent using propositional variable, and then determine the appropriate logical connective. Okay, so if you notice just now, you identify dulu whether that statement is proposition or not, and then you akan assign variables, and then you can determine appropriate logical connective. If I go to, this is the sentence that you got in English statement. If I go to Harry's or to the country, I will not go shopping. So how many sentences? My first question. How many sentences we have here? First, second, third. And then that will be the first thing. You identify whether it is a statement or not. Next, you assign, you represent using propositional variables. So next, you will assign the variables to this statement. Clear? Alright? And then after you have get this, then you will translate this into here. Into the apa nama logic connective. Boleh? Okay? Alright. Okay, so this is the example. Okay, you can try by your own. Okay, system spec, translate sentence from natural language into logical expression is an essential part of specifying both hardware and software system. The most important things why you need to identify all the statement, all the operation. Okay, just imagine when you graduate nanti ataupun tak graduate lah, you pergi internship nanti, you akan di-assign untuk mungkin tak lead project pun, but then you will need to follow your seniors to meet your client. Alright? So usually client, if the client doesn't have any computer science background, they will just briefly mention to you what they want. So you yang dah ada knowledge, because now you have this knowledge, the discrete knowledge, the logic knowledge. So you will extract those sentence from your client into a logic statement. So that from that logic statement you can translate it into system. That is one of the reason why you need to learn all the logic ni lah. Kalau you perasan, bila you have a conversation dengan orang, dia akan guna bahasa pasar. Kan? Layman language. So you yang ada technical knowledge, you kena translate benda tu. Clear tak? Dapat tak? Reason why kita belajar benda ni. Nampak tak ada kaitan kan dengan programming kan? Tapi dia ada belakang tu. Boleh? So that's why kalau kita kat sini, the applications, system spec consistent lah. Lepas tu nak kena translate pula daripada natural language kepada ini. So itulah kepentingan kenapa kena belajar benda ni. Okay? Good. System spec should be consistent. That is, they should not contain conflicting requirements that could be used to derive a contradiction. Okay? When specs are not consistent, there will be no way to develop a system that satisfies all specifications. Faham tak lagi maksud apa? So, bila you develop system, you kena make sure dia tak contradict. All the statement that you translate, dia kena consistent. Boleh? Kalau that's why we need to know about the equivalence. Kalau you perasan, if you notice the equivalence just now, for the example this one, let's say you have these two requirements from your client. Your client A, dalam team yang sama, your client A say like this, in your day one, the next day maybe they send someone else, and that someone else maybe they use this language. So you, as a developer or as a project manager, you kena make sure the first person and the second person, they have the same thing yang they want. You just can imagine if let's say the first person say, contoh yang say like this, and then the second day the second person say like this. So macam mana you nak buat sistem tu? Because the one who are going to develop is you. So that one, it is very important for you to know to construct ataupun to extract all the statement from your client, translate into logic. Boleh? Boleh tak yang itu? Alright. Tadi kita kat mana? Consistent system spec. Kecilnya. A list of proposition is consistent if it is possible to assign true values to the proposition variable so that each proposition is true and does not contain any conflicting requirements. Sekarang pukul berapa? 10.44. Kenapa pukul 11 kan? Dia buat kita ada orang. Okay. Alright. So this fact is consistent. Okay. So if you look into here, we have three statements here. The first one is the diagnostic message is stored in the buffer or it is transmitted. The second is the diagnostic message is not stored in the buffer. The third, if the diagnostic message is stored, then it is transmitted. So now you have this sentence, and then you need to assign the variables to all the statement here, and then by using a truth table, you can see whether this statement is consistent or not. Alright. So kalau you tengok kat sini, you dah translate dia, you dah dapatkan dia punya variables, you dah translate setiap ni kepada connective. By using a truth table, you check truth table untuk setiap ni sama ke tidak. For this case, when P is false and Q is true, all these statements are true. So the spec is consistent. And soalan dia, what if the diagnostic message is not retransmitted, is added? What if they add another statement here? So nanti you akan tengok the spec tu tak consistent. So this one you can try to use the truth table untuk check, untuk compare the three statement here and then the four statement. Boleh kan itu? Boleh ya? Alright. Okay, web page searching. Ini pun biasa kan kita guna kalau kita nak, if we want to do the searching, we use the and, we use the or, kan, common kan biasa kita guna. And then tak ada apalah. Okay, logic circuit. So ini betul-betul nak speed up ni. Ni rasanya kita bikin sikit lagi. So logic circuit, untuk logic circuit ni tak kita fizik benda tu. Okay. So dia lebih kurang je. Okay, so electronic circuit, each input or output can be viewed as 0 or 1. So 0 false, 1 true. Okay. So now a complicated circuit are constructed from these three basic circuit gates. like a D there. So for the inverter, okay, we have the P and then we have the negation P. Alright. For the OR, okay, for the OR we have two statements PQ, and then after this P and Q go through this OR gate, it will give us POQ. Same goes to the end. We have two statement here PQ. After it goes to the AND gate here, it will get P and Q. Okay? Alright. So the inverter is the NOT gate or the negation. Alright? Takes an input bit and produce the negation of that bit. The OR gate takes two input bits and produce the value equivalent to the disjunction of the two bits, and the AND takes two bits sama and produce the value equivalent to the conjunction of the two bits. Okay, so more complicated digital circuit can be constructed by combining these three to produce the desired output by given the input signal by building a circuit for each piece of the output expression, then combine them. So if you notice here, we have three arrows at the beginning. So we can say that we have three inputs for the whole system. Okay, so we have P, Q, R, but the P, it will go to the AND gate. And now we have the second statement here, the Q. The Q, it will pass through the negation gate. Okay, so after it passes through the negation gate, it will give us negate Q. Okay, and then the P and the negate Q pass through the AND, then we get this one. Okay, the R it pass through the negation gate, it will give us negate R, right? And then the combination or this one, okay, the P and negation Q pass through OR gate with the negate R, then we will get the final output. Itu je, simple kan? Okay. Okay, logik puzzle tu tak apalah. So I think we will end here. Alright. So for this one, we will proceed next week. Okay. Yesterday, we don't have class, right? So actually it's compulsory for me to replace the class. So is it okay if I give you an exercise and we are assuming that by you submit the exercise, then I consider it as kelas ganti, as replacement class. Yeah, boleh? So I will share the exercises and you will need to submit it on Putra Blast. Macam biasa. Boleh? Macam biasa. Tak biasa lagi kan? Okay? Right, so I think that's all for today. So thank you so much. Lepas ni kelas kat mana? Oh, tak ada kelas lagi. Betul petang? Oh, kedua. Kelas apa? Hah? Problem solving. Jom ambil gambar je. First class kan? Tak jom? Pergi tak jom? Kan? Mana lighting lawan? Sini, masuk. Sana tu, sini. Yang boy, come. Nampak tak semua? Saya tak tahu yang belakang. Itu tak ada. Okay, 1, 2, 3, cheese. First class kan? Welcome to UPM. Dah habis kelas baru nak. Okay, thank you. Liu. Alright.
Thank you, teacher.
Okay, thank you. Bye-bye.
Bye-bye.